All right, today we're going to cover topic 6.6, and the title is Integrals as Areas. This is actually a two-part lesson on topic 6.6. We will finish the second part tomorrow. And when you see that integrals as areas, you might say, well, I thought that's what we've been doing. That is correct, but we should probably add the word known. Known areas. So what we're dealing with here is these are all going to be known geometric shapes. So for example, look at this first example right here. This is the integral of a constant function. So on all of these today, you need to draw a picture. This is just a constant function going through 5, 4, 3, 2, 1, and we're evaluating it from -3 over to 5. So this is just quite simply the area of a rectangle. Block it off. Okay. Area equals length times width. The length we can see is 8. The width is 5. This is 40. So we could say that the integral from -3 to 5 is 40. All right? This is what we mean by a known area. All right? Now, this one requires a little bit more thought. We'll call this one example 2. This is the integral of an absolute value function. And we know that this absolute value function has been shifted to the right 4 units. Okay? So we've got this and we've got this going on. And we know from what we've learned about absolute value functions that this is just x minus 4 with a reflection. All right? So over here, we've got x minus 4. Over here, we've got negative x plus 4, which means this y-intercept over here is 4. All right? So what we're doing is, once again, we're going from 0 to 6. I'm going to find this area of this triangle, and I'm going to add it to the area of this triangle. And again, those are known geometric shapes. We just have the area equals 1/2 the base times height. The base on this first triangle is going to be 4. The height is going to be 4. So we're half of 16. That's 8 on that one. On this other one, we've got the area of 1/2 times 2 times what? Now this height is not 4, is it? If I put a 6 in right here, 6 minus 4, that height is 2. So this is 1/2 of 2 times 2. All right, how did I get that? Remember, the height is 2 because I put a 6 into this x minus 4. So half of 4 is 2. 8 plus 2 is 10. And we have evaluated this integral using a known area. Now, part of what you have to be able to do is recognize things. This is a circle. It's actually a semicircle. We've covered that. And that would be a whole other lesson to review why that's a semicircle. But all we're doing on this problem is we've got this semicircle with a radius of 5. All right? The radius is 5, but we're only evaluating the integral from 0 to 5. So we're only looking at this area in here. So this is just the area of a circle, pi r squared, divided by 4. That's all we would have to do on that problem. The radius is 5, so I will have 25 pi fourths. And we have evaluated that integral using a known area. All right? Now these last two problems both have a couple of wrinkles that I want to go over with you. This was example 3. So this is example 4 and example 5. All right? Example 4, we have a linear going through 5. All right? Its slope is -3. If I set this thing equal to 0 and solve it so that I can find the x-intercept, I find that the x-intercept is 5/3. Why does that matter? Because I'm evaluating this integral from 0 to 4. And so there most definitely is a portion of this graph that has a negative area. That section is a negative area, and this section over here has a positive area. So you have to break this up into two triangles, and this area you will need to subtract. All right? And so that's the clue on problem 4. On problem 5, once again, we need to be able to draw this function appropriately. This thing is a linear going through 3. All right? But we're only evaluating it from 1 to 5. So we're evaluating it from 1 to 5, which turns this thing into our old friend, the trapezoid. And we know that the area of a trapezoid is the average of the bases, base 1 plus base 2 divided by 2, times the height. Well, my height is easy on this problem. The height is 4. Okay, this is the height from there to there. But the bases are going to be function values. So I would have to plug 1 in up here, all right? 2 times 1 plus 3, that's going to be 5. And then plug in the 5. 2 times 5 plus 3, that'll be 13. 5 plus 13 divided by 2. All right? That's 18 divided by 2, which is 9. The area of this one is 36. All right? And we will stop there for today.